So BGP confederation. Why we need BGP confederation? As we know that if it is an IBGP, we need a full mesh peering in order to advertise the routes to every router, BGP router. We need a fully mesh. We need to have full mesh. We need to have neighbor with every router inside the IBGP autonomous system, inside the autonomous system. We need to have neighbor, we need to have peering with every router, every BGP router. Now what's the problem in that? The problem is too many neighbor adjacency we need to configure, so more process utilization, the database becomes bigger. In order to reduce that, we go and do any of these two techniques. One is confederation, the other one is route reflector. Both confederation and route reflector solves the same problem. Confederation and route reflector. Confederation we will see first, and then the route reflector. So what do they solve? They reduce the number of peer relationship that we form in an IBGP environment. What if I don't have more peer relationship in IBGP? Routes will not be advertised. Why? We know that in fundamentals we learned that we have something called BGP split horizon. What does it say? Route learned from one IBGP will not be advertised to another IBGP. Because of this, the third hop router will not learn the route advertised by the first router. To overcome this, two solutions are available. One is confederation, other one is route reflector. The confederation is what we are going to understand. Let's see this diagram. And what I see here is I have 6 routers in autonomous system number 1. 6 routers in autonomous system number 1. Now how many neighbors each router need to have, or how many peer relationship I need to have, or how many peers I will be configuring on each router. You can see that each router is connected to the opposite side, that is three neighbor, and one below 4, and also one which is not directly connected. So totally, as you said, 5 neighbor command I need to type on each router. Now totally I have 6 routers, so 6 5s are 30. So you will be having, one second, I think our calculation is wrong. Yeah, you're right. Each router will have 5 neighbor. So this is one small formula in which we calculate n minus 1. So n, how many neighbors we have? We have totally 6 router. So 6 minus 1, 5. Yes, we say 5. And how many routers we got? We got 6 routers. So 6 into 15, 6 into 5, 30. 30 divided by 2, 15. So we need to form 15 IBGP neighbor. 15 IBGP peering configuration that we will be doing on all 6 router. 15, right? 15, which means, let's have a small calculation. So from here I'll say 3 router, 1 2 3 neighbor, and then 4 neighbor, and then 5 neighbors. So 5 neighbors from here, Similarly, 5 neighbors from here, 5 neighbors from here. Hey, it comes around 15 plus 15, right? Here it comes around 30 peerings. 30 peerings. It's not 15. Anyway, we will see that when we do configuration. I'm slightly confused now. So what we are understanding is we are having too many peering configuration. We are having too many peering configuration when we have IBGPs. So the reason is because of split horizon we need to do that. What is the solution to avoid it? The solution to avoid this is the confederation. How you solve this problem in confederation? We create multiple sub-autonomous systems inside the main autonomous system, like this. So the actual autonomous system is autonomous system number 1. We create sub-autonomous system inside the main autonomous system. Why we do that? We do that so that these two routers will not feel like an IBGP. They will have a feeling of EBGP, and they will have the routes sharing. So in order to give that feeling, in order to make these two routers to understand themselves as an IBGP, EBGP, in order to make them to feel as an EBGP, we put them into different autonomous system inside the main autonomous system. So whatever the route that is coming from 546 into 123 router, it advertises to this router. But again, it will not advertise to below router. If you want that advertisement to happen, again you need to have a fully mesh here. Anyhow, by just dividing into two subautonomous systems, you are reducing the number of peering into half. Previously, if it is 30, then this time it is 15. Previously, if it is 15 peerings, then now you are reducing to 8 peerings. Why? I need not to do fully mesh with all the 6 router. I need to have fully mesh only with this 3 router in the left and with this 3 router in the left. So the number of peering is reduced when I do the sub-autonomous system or when I do confederation. If you don't like fully mesh within the sub-autonomous system, again you can break down into another small autonomous systems, or I can use route reflector here and here. Anyway, I'm not going to confuse you with route reflector now. We will be seeing that as a next topic. If you don't want to go with route reflector, then you can have fully mesh within the sub-autonomous system and within the sub-autonomous system. So how many neighbors you will have on each router? I'll say 2 neighbors. Only 2 IBGP neighbors. IBGP neighbors. Yeah. So here 2, here 2, here 2. So 6 here in the left. Similarly, here 2, here 2, and here 2. 6 in the right. 6 in the left and 6 in the right. It is 12. No, that's the mistake I was doing in the previous diagram. See, why I need to... Here I make 2 and here I make 2. Yeah, right, correct. 6 plus 6. Sorry, totally 6. Here 2, here 2, and here 2. 6 in the left, 6 in the right. So it is 12 now. Previously, according to our calculation, it was 30. It was 30. Now this time it has become less than half. 12. Right. Now previously if it is 15, then it is 8. But we will see this one during the configuration time. Next. So that's the advantage of having the sub-autonomous system inside the autonomous system, which we call it as confederation. Now, if you are creating sub-autonomous system, use the number between 64512 to 65535. 64512 to 65535 are called as private autonomous system number. See, like a public IP address, autonomous system number also need to be unique. Why? BGP works between autonomous system. It works between autonomous system. In public world, those autonomous systems are advertised to other autonomous system, and it is the autonomous system that helps BGP to prevent loop. So what is the loop prevention mechanism in BGP? Autonomous system number. So you cannot have two same autonomous system numbers. Autonomous system number should be unique. But every ISP will have their own unique autonomous system number. Every ISP will have a unique autonomous system number given by the organization which maintains it. Now, the sub-autonomous system number, or like private autonomous system number. Yes, please. Question. Yes, what is your question? I didn't understand. See, every ISP has got their own autonomous system. One. Why they want more than one? Only one. Right. So they may be connected to more than one ISP, more than one autonomous system. Right? They may be connected to more than one autonomous system, but for an ISP, you'll have one autonomous system. Now, a sub-autonomous system number, you can use a private autonomous system number. Right, but it is recommended to use this, but what I'm coming to say is the sub-autonomous system numbers will not be revealed to the outside. So, any autonomous system number you can use as a sub-autonomous system number. That won't cause a problem. Why? Your sub-autonomous system number are not going to be advertised outside. The outside world will never see your sub-autonomous system number. They will see only the main autonomous system number. But it is recommended to use a private autonomous system number as a sub-autonomous system number. Right. So what we will do is we'll quickly build a topology and see how to configure BGP confederation. So let's start basic configuration. This is the topology. We have 8 routers, and I would like to put this middle one in an autonomous system. So we will call this autonomous system as autonomous system 2, and so R1 configuration goes like this: enable config T interface F0/0 no shed IP address. We'll have here 12.0.0.1 255.0.0.0. I'm giving a public IP address between R1 and R2. Interface loopback 0, I would like to give 1.1.1.1 255.255.255.255, and also I would like to run basic BGP. We all know BGP, right? Basic BGP. So router BGP 1 neighbor is 2.2.2.2, remote AS is 2, neighbor 2.2.2.2, update source loopback 0, and neighbor 2.2.2.2 EBGP multi-hop 2, because we are using loopback. And I don't think anything more is needed, so I'll say write to memory, copy. I'll paste this on router 1. I made some mistake. So I'll again copy and paste it once again. Done. Similarly, R3 configuration I would like to finish before we go to the other router. So 3.3.3.3, and the IP address here I would like to give as 78.0.0.8. 8. And our BGP is 3 here. Neighbor is in same remote autonomous system, but the address is 7.7.7.7. Okay. Now I'll copy and paste it on router 8. Alright. So next is about R2. Let us configure R2. R2 F00 will have 12.0.0.2, and loopback will be 2.2.2.2. And let me finish EBGP. EBGP will be 1.1.1.1. Remote AS is 1. 1.1.1.1. 1.1.1.1. That's it. So this is for EBGP. Let us also continue doing for IBGP. So further I need to have some more interfaces. So interface F01 no shed IP address will be 192.168.23.2 255.255.255.0. I would like to run OSPF within this autonomous system, so I'll say IP OSPF 1 area 0. I would also like to run OSPF on loopback interface, so I'll say IP OSPF 1 area 0. I always prefer putting loopback interface on top. So let me go to the top. Right. Zero one is over. Similarly, we got another 2 interface here. F1/1 will have 26.2. f1/1 has got 26 and f1/0 has got 25. Alright. Now, because we are going to do confederation, okay, let's assume we don't have confederation. Now let us see how many neighbors we will form. How many neighbors we will form? We will form from R2. I need to form 5 neighbors. You're right. 5 neighbors, IBGP neighbors, 5. And totally we got 6 router, so 6 5s are 30 neighbors we need to form. 30 neighbors. Even though you may be using a loopback address, even though we use a loopback address, it is 30 neighbor statement, which is too much. In order to avoid this, only we go for confederation. So what confederation does is it helps. By creating sub-autonomous system, it helps to reduce the number of peers by giving a eBGP relationship within IBGP. So for that, what I'll do is I'm not going to concentrate on BGP now for autonomous system 2. We'll come later. We'll do BGP for autonomous system 2 later. So I'm going to just paste this alone. Is it okay? BGP will do separately. Just basic configuration with eBGP configured. I am pasting it on R2. Now I am expecting an IBGP neighbor between R1 and R2. Show IBGP summary. Okay, this will not come up. The reason is we don't have a route. So let's write a static route. IP route 1.1.1.1 255. Send it to 12.0.0.1. Similarly, I also need to do it on R1. IP route 2.2.2.2 255.255.255.255. Send it to 12.0.0.2. Yeah, now the neighbor has come up. Similarly, on R7 will finish the configuration. On R7 I'll just keep the basic stuff. R7 is forming neighbor with 8.8.8.8 8.8.8.8 and R7 has got 4 links. So loopback will be 7.7.7.7. F00 has got 78 7 and F01 has got 47.001. 01 has got 67.7 and 11 has got 37.7 and 10 has got 47.7. That's all. So I copy this and paste it to router 7. Done. Next, here also we will not form a neighbor because of the route problem. I'll say IP route. In order to go to 8.8.8.8, you for 5 dot send the traffic to 78.0.0.8, which is router 8 address. Similarly on router 8, IP route 7.7.7.7 255, send the traffic to 78.0.0.7. I'm expecting a neighbor here. Show IP BGP summary. Ping 7.7.7.7. It's pinging. Show IP interface brief. Oh, you see the loopback address is wrong. Interface loopback 0, IP address is 8 dot all right. With the source of loopback 0. Open confirm idle. So the problem is because of the router ID. Show IP BGP neighbor. The neighbor could not establish. The problem is the BGP identifier is 333. Let me go and say router BGP 3, BGP router ID is, this is what's a 8 router, right? 8.8.8.8. Show run section BGP. Never sends on unique space removed from session. BGP notification. Okay. So what do I see here is the remote, the autonomous system number, remote, everything is looking good. I'll go to router 7. Okay, this is the autonomous system number problem. There is also one more problem. Autonomous system number is 2. Here it is mentioned correct. I think in router 7 I have made some mistakes. Show run section. If you'll get FFF like this, it's autonomous system number mismatch problem. Okay, you see, that's the problem. Remote AS I have said 1. It should be what? 3. That's the problem. Yeah, it should be 3. No, 888 is 3. You didn't. 888 is 3. Let me show you one more time. So whenever you see remote AS, I put 1. So what I'll do is I'll create the no router BGP. I have removed BGP and I'm putting back route BGP 2, and the neighbor is 8.8.8.8. Remote autonomous system is 3. And then update source is loopback 0. eBGP multi-hop. So now I'm expecting a neighbor. Alright, show IP BGP summary, we got neighbor. What is next? The next is from router 3 I would like to advertise a network. So sorry, from router 8 I'll have interface loopback 33, or I'll have interface loopback 8. I'll say not 8, I'll say 88, and say IP address 88.88.88.88. This is for testing purpose. This network is for testing purpose. So what I'll say, I'll advertise this router, or I'll advertise this network under BGP. Router BGP 3, network is 88, mask is 32. Right. Now if I go to router 7 and say show IP BGP summary, I should see one prefix learned. Show IP BGP 88.88.88.88. I'm seeing that that network is being learned. It is learned from the autonomous system number 3, and it is not advertised to any peer so far because we don't have any IBGP peers, and it is coming from the neighbor 8.8.8.8. Okay, it's BGP version 2 because it's IP version 4. You can also see like this, show IP BGP. You can see here it is valid and best. It's coming from AS path 3. Alright, now this is good. Let us go and configure basic configuration on R3, R4, R5 and R6. R2 is done. Basic configuration. I'm going to R3. So I remove BGP as for now. No BGP configuration. So I'm doing for router 2, I'll say 2.2.2.2 and F001. Oh, I think 2 is done. 2 is done. 3. Let's finish 3. How many interface 3 has got? 3 has got 4 interface. Yeah, we'll finish 3. And F00 will have 23. Yeah, 6 interface, that's right. Oh, I didn't put any network here. Okay, the network here will be (36). Okay. All right. Now, router 3 has got more interface. Let's finish that. F00 will have 23. F01 has got 34.3. F1/1 has got 35.3. And F1/0 has got 36. And we got one more interface called 2/0. That will have 37.3. Alright, so this I'm going to copy and paste it on router. Yeah, paste it on router 3. Let us verify. Thank you. Alright, so let us now check. I see only one neighbor 777, but I supposed to get neighbor even with router 2. Show IP route, show IP OSP of neighbor. So something is wrong with router 2 and router 3. Show IP OSPF interface brief. I'm seeing OSPF running on I'm not seeing OSPF running on F00. You see, I'm not seeing OSPF running. So that may be interface down. Show IP interface brief. No, we have configured, but we didn't put in OSPF. IP OSPF 1 area 0. So that was the issue. So I'll also change in the notepad because I'll be using the same configuration on the other router. So here IP OSPF 1 area 0. Done. Next is R3. Okay, R3 has got 2 neighbors now. Show IP OSPF neighbor. I got 2 neighbors and 2222 and 777. Okay, let's finish configuring R6. In R6 also we have 5 interface. So by this, using this notepad, we can do it very easily. So this will be 6.6.6.6. 00 will have 56.6. 56.0.0.6. F01 will have 36.6. And F01/1 will have 26.6. 26.6. And F01 will 10 will have 67.6. 67.6. 46.6. And then what else? I think we have done everything. Let us copy this. One more thing I should do here. And copy, paste it on router 6. Alright, now I'm expecting 2 neighbors. No, 3 neighbors. Is it 2 neighbor or 3 neighbor? 3 neighbors. One with router 2, the other with router 3, another with router 7. 2 is already up. Neighbor is up. Show IP OSPF neighbor. Only 2 is up. Need a troubleshoot. Show IP OSPF interface brief. OSPF is running on all this. but neighbor I have only one. 67. I have configured 67, I remember. Show IP OSPF interface brief. Okay, here also the same problem. No, there's a big mistake done here. 0/1 has got 67.6. No, there is no mistake. There is no mistake. This is correct. Then why am I not seeing? Show IP OSPF neighbor. I'm not seeing OSPF neighbor with 6. It's IBGP 67.ping. That's the problem. So there is some issue with the address. Let's go to router 6. .6. Yeah. 0/1. Actually here it should have 67. Wrongly configured. Interface F1/0 goes to default. And then 00 is correct. 1/0 is not correct. 0/1 1/0 is not correct. Okay, that is interchanged. 0/1. Okay, now on 0/1 let's finish first 1/0. 1/0 will have IP address of 67.6, correct? No, 36.6. 0/1 will have 0/1 will have 67. 0/1 will have 67. Alright, I change it. IP address and then 1/0 will have 36. Okay, IP OSPF alright. So as we expected, we will be seeing now 3 neighbors. Show IP OSPF neighbor. We got 3 neighbor. Alright. Similarly, router 3 will also have 3 neighbor. Alright, next is let us finish just 2 more routers left. So let us finish router 3 at the bottom, router 5 at the bottom, 5. router 5. Router 5 has got only 4 physical interface. And 00 will have 56.5, and then 01 will have 25.5, and then 10 will have 35.5. I'm sorry? Oh yeah. Yeah. That's all. There is no 2/0. I remove this. Select all, copy, paste it on router 5. Now I'm expecting 3 neighbors. Show IP OSPF neighbor. Okay, 3 neighbor has come. Done. So similarly, one last router need to be configured. Zero zero will have 34.4. 10 will have 46, or 01 will have 47 dot, sorry, yep, correct, 47.4. And then 10 will have 46.4. That's it. So copy all, paste it on router 4. Just done with the basic configuration. Now what is next is the BGP. See, for BGP what I'm going to do is I'm going to divide this autonomous system 2 into 2 small sub-autonomous systems. So I'm going to divide into 2 small sub-autonomous systems. I'll duplicate it. I'll give a color, maybe light blue color for one, and the one I'll give different color, light yellow. Okay, so this is one autonomous system, and this one is another autonomous system. 2 autonomous systems. Right. Now what I'm going to do is I'm going to write here the sub-autonomous system. Sub-autonomous system, I'll say sub SAS. I'll call this as 65531 sub-autonomous system. A private autonomous system I'm giving, but it is not really necessary because this autonomous system will not be advertised to the other AS1 and AS2. AS1 and AS2 will not be knowing about this sub-autonomous system. Right. So the main AS is 2. The main AS only the other autonomous system will be learning. Alright. So let's do this. on R1 what I'm doing is, no, not on R1. R1 there is no change. Our ultimate goal is from R1. See, one more thing I want to do it on R1. On R1 I'm going to advertise the network. Router BGP 1 network 11.11.11.11 mask 255.255.255.255. And then what I'm going to do is interface loopback 11, IP address is 11. I am advertising it. So our ultimate goal is to ping from this loopback to 88.88.88.88, which is in autonomous system 3. You understood the ultimate goal? Show IP BGP. Right now we are advertising 11, but we are not learning 88. The reason is the transit autonomous system is not still advertising it. We have BGP on 7, we have BGP on 2, but they are not IBGPs. So I want you to now consider R2, R3, R4 as one autonomous system, 65531. I'll give different color to it. The color will be white, not white, black. It's already in black. I'll give different, maybe thick green. And no, still it is dull. I'll make font size a bit bigger. So consider this 3 as one autonomous system. So whatever you will do for this blue autonomous system, if it is single autonomous system, you need to make this fully mesh. R2, R3 and R4 need to be fully meshed. So you do that. So let us do that one first. Enable config T interface, sorry, not interface, router BGP to BGP, sorry, you're right. It is not 2, it is 65531. Now, what will happen is, we already have a BGP called BGP2. That will cause problem. So let us remove that BGP2 first. You cannot have more than one BGP. So remove BGP and then now say router BGP 65531. Okay, then if it is 31, then next will be 32. Okay, 32. Yeah, definitely now we will lose eBGP connection, but I'll show you how to bring the connection up. Right? On the customer side or on AS1 and AS2, we are not going to change the autonomous system number for the neighbor. For the neighbor, still the autonomous system number will be 2 only. On AS1, we are not going to change it to 65531. We are not going to do for neighbors any change autonomous system. So what I'm going to do is, I'm going to show you what we're supposed to do. After cancelling this and putting the sub-autonomous system, you go inside and give this command BGP confederation. Is the spelling right? CONFEDERAT, correct. Confederation identifier. Now what is the actual autonomous system number? 2. That's all. That solves the problem. So even though your autonomous system is this, for eBGP it will not be shown as this. It will be shown as this. You got this? Next, neighbor. I have a neighbor 5.5.5.5. That is an eBGP neighbor, correct? Because it's another subautonomous system. So that neighbor is in autonomous system number remote AS 65532. Now because you are using this, you need to say that as a confederation peer. So BGP confederation peer is everyone that is in 65532. You understand? We have to give this. If you have many other subautonomous system, you need to say all subautonomous system. Right now for blue there is only one subautonomous system, which is yellow. So that I need to put under peer. One more thing, what I forgot to do is this. Neighbor, for eBGP neighbor, remote AS, because I removed BGP, right? I need to put it back. Remote AS is what? 1. To that same neighbor, 100.100.1, update source, zero. To that same neighbor, 100.100.1, eBGP multi-hub. Hope you understood. These are the two main commands for you to understand confederation. Why do I give this command? So that I'm telling my eBGP neighbor that this is my autonomous system. Why do I say this command? This command is to say that you are having another eBGP neighbor, but that is not actually eBGP neighbor, that is confederation neighbor. Next. And then what else? I'll form IBGP with fully mesh with R3 and R4. So R3 is neighbor. Three one you will be saying only on router 5 and 5, 6 and 7. IBGP between R2 to R3, no? Yes, see, I'll write now, you will see that. See, 3333 is IBGP, right? So remote AS will be 31. This is what you are asking, right? No, once you mentioned is enough. So this is for router 4.4.4.4. See, this is what fully mesh. What is fully mesh? Giving all the IBGP neighbor. 4444 is not directly connected, but we have to give it only then. Route from R2 will be given to R3, and R3 will, and route from R2 will also be given to R4. So this time we have only 3 neighbors. We have only 3 neighbors. If you want to have from R2 to R6 fully mesh, not necessary actually, you don't need to do that. We will have eBGP only between these two, R2 and R5. R2 and R5. So now wait, what we have done is 5, 3 and 4. That's enough. Perfect. Perfect. Now next is that's all actually. End, write to memory. I'll copy this. Is that clear so far? I'll paste this on router 2. Okay, neighbor is deleted and new neighbor will be given. Fine. Now I'm expecting another neighbor. Look at this. BGP neighbor has come up now. Okay. Now let us go to R1 and check the neighbor. Show IP BGP summary. From where do I have the neighbor? I want to show you. Okay. Who is my neighbor? Neighbor autonomous system is 2. It is not showing your private autonomous system. You understand? Private autonomous system is not revealed to the public. So let us do the similar configuration on R7. Let's finish R7. What do you say? So R7 also we cancel BGP2 and instead of 31 we put 32. Identifier is 2 and 8.8.8.8. Remote AS is 3. 8.8.8.8. Loopback 0. Update source. eBGP multi-hop. Confederation peer is what? 31. Correct? For router 7, 31. And this will be 4. Okay, leave this one. Leave this one. So the other 2 has to be altered. This will be 6.6.6.6 and this will be 5.5.5.5 and this will be 2. Correct, no? Select all, copy and paste it on router 7. Now I'm expecting 2 neighbor. Can you say who are all? Those 2 neighbor. One is router 8. No, 4 we have not configured BGP. Yeah, router 2. Because we are running OSPF. Show IP BGP summary. But it is not forming neighbor with router 2. The reason is on router 2 we have not set 7 as a neighbor. Correct, no? Router 2 and router 7 are not neighbor. We have not configured 2. We are forming eBGP only with router 4. R2 and R5, but R5 and R7 is neighbor. R5 and R7 and R2 is not neighbor. See, you need to understand one thing very clearly here. R2 and no, next up self is not the problem here. You see, try understanding what I'm saying. Router 2 and 5 is neighbor. But 2 and 7 is not neighbor. 2 and 7 is not neighbor. See, I don't have 2. But you see, there is a good news. No, sorry. Still, we have not finished. It needs to form neighbor with R4 to get the update. You understand? Similarly, R5 should get form neighbor with R2 to get the update. So we need to configure R5 and R4 now. Let's start from R5. R5, again same configuration, these are all same, and here it will be neighbor is, no, there is no eBGP, so no need to worry about this, but still you need to give the identifier and a peer. What is the doubt? Okay, let me finish this and yeah, When you have the doubt, when you remember the recall the doubt, you let me know. So from R2, no, this we are going to do it for R5 now. For R5 again, I have the same identifier. I have the same the peer group command. From R5, the peer is confederation peer is 31 65531, and my neighbors are 5555. Sorry, 2222, and then 6 and 7. Correct? No. And they belong to 32 65532. I'm going to paste this on router 5. Now let's go back to 7 and verify the neighbor. I'm expecting a neighbor with 555, ping 5.5.5.5 with a source of loopback 0. I'm able to ping, but I'm unable to form neighbor. You know the reason why? We didn't say the update source command. We didn't say the update source command. Correct? No? We need to say the update source command. So this I need to say for 7. For 6 also I need to give. Even for 2 also I need to give. So it is like same like indirectly connected loopback to loopback. So for 6 and for 2. One more very important thing I need to do. You know what? Because router 2 and router 5 is looking like an EBGP, I need to give even multi-hop command. You understand? You understand? Multi-hop command has to be given for 2222. Yeah, from 2 I need to say for 5, and for 5 I need to say from 2. Done. Now I'll again copy and paste it on router 5. Similarly, I need to do it on router 2, router BGP, this, router BGP, okay, 4444, update source loopback 0, and 3333, update source loopback 0, 0, 5555, update source loopback 0, loopback 0, and then I also have 5555 EBGP multi-hop 2. Okay. So I'm expecting a neighbor. Look at this. We got a neighbor with 5 now. Now I'll go to router 7 and do some configuration. On 7 I need to do something. On 7 show run section BGP. Okay, here also I need to say update source. So to 4 I need to say two things. Update source loopback 0. I also need to say EBGP multi-hop 2. And then with not necessary with 4, not necessary at all. I'm just having for redundancy sake. In case if this connection goes down, just for redundancy, not really necessary. One EBGP between 2 and 5 is more than enough. Right, I need not to even have neighbor with this. For redundancy I'm having. And what is next? 6. Correct. So for this neighbor, I'll say update source loopback 0, and with router 5, with the neighbor 5, update source loopback 0. Okay, actually to prove confederation I can stop here itself, but still we were planning to ping from R1's loopback to R8 loopback. So let me proceed. Before that I'll show you something. Show IP BGP. I'm seeing 88.88.88.88. Still I'm not getting 11.11.11.11. So let us now try to see 11 network on router 5. Show IP BGP. Here I am seeing 11 as well as 88, and I am very clearly seeing that 11 is coming from private AS. See, in private AS you will see inside the confederation you will see the private AS, and one is actually coming from where? Actually one is coming from 11.11.11.11. Now what is the problem? Next up self command is what we have not given. Correct, na? That is why it is not a best one. So we'll go to router BGP, and then for each neighbor, so what are the neighbors? 3.3.3.3, next stop self, and for 5.5.5.5 also I should say. Not needed, you're right, it's an EBGP. And then, yep, 4.4.4.4. No, 5.5.5.5 also needed. Why, Why? What is next up self? Next up self changes the source ID. See, that is correct. But from where the update is coming? Update is coming with the next stop address of 1111. R5 don't know how to reach 1111, correct? See, update is coming from 1111. R5 don't know where is 1111, correct? R5 still don't know where is 1111. So if the next stop address is 2222, only then R5 can reach that, correct? Sriji, the next stop address should be a reachable address. That is why we go and say next stop self. You understand? Going to router 2 again. Okay, now let us go and verify on R5. Give some time for the convergence. Meanwhile, I'll go and check it on R2. Show IP BGP. Here I see 1111. It is valid and best. I'll check it on R3. Oh, R3 we have not configured. I'll check it on R4. Oh, R4 also we have not configured. Sorry for that. Now let me check it on R5. R5 is the place, so I need to check it. See, 11 has got valid and best. For 11, I learned the route on R5. You understand this? Now I will see 11 on R7 also. On R7 also I'll see 11. See, I am seeing 11. You understand? I am seeing 11. So I need not to really enable BGP now on 3 and 4. It is not mandatory. But if you want, you can have it. But I need to enable BGP on 6. Because it has to forward the traffic. If you want a multi-path to be taken, then you need to enable on 3, 4 as well. Right? So now, let us go to R8 and check whether we are learning 11, R8. Show IP BGP. No, I have not configured. R3, R6. No. R3 and R6, they are not running BGP. See, show IP BGP. There is no BGP active on R3. Even R4 also, no BGP. R6 also no BGP. No BGP. So we should have BGP for pinging purpose. See, we have already learned route on R8. We have already learned route on R8. 11 is coming from 7777, which is router 7. And see the path. It is not showing our sub-autonomous system. You understand? Right. Now, if you really want to ping, 88 should be seen on R1. But 88 is not seen on R1. Look at this. Show IP BGP. 88 is not seen. Let us troubleshoot. First of all, let us go to 7 and check what is 88. Do we have 88 on 7? Yes, we have 88. But the next stop address is an unreachable address for R5, R6 and R2. So what do? You go and say next stop self. Router BGP 655.32 neighbor 5.5.5.5 next stop self, and also you will have 6666. For that also we need to say next stop self. If you will have 4, for that also we need to say next stop self. Now, if I'll go to R2 or if I go to R1 itself, I will see 88. Give some time, it will come. See? You understood? Right. But if I ping, I will not be able to ping. If I ping, the packet will get dropped. R6 is not configured. No, if one is fully meshed, that is enough. Actually, if I make R6, if I make one of the autonomous system, packet will go like this. Instead of going R2, R3, R4, it will go like R2, R5, R6, R7. You understand? Now what I'll do, I'll go to R6 and configure BGP. Router BGP 655.3. Yes, it needs to be fully meshed. Alright, this is done. Now what is next? Neighbor. How many neighbors? Or I'll do one thing. I have I have the configuration here. So I have only two neighbors. From R6 I have only two neighbors. That is 5 and 5.5.5.5 and 7.7.7.7. I don't have neighbor with 2. I don't want. If you want, you can have it. And update source, yes. And then with 2, if you want, you can have, but I don't want. EBGP multi-hop and all not necessary. That's it. Now I'm going to copy this and paste it on router 6. Done. I'm expecting two neighbors. Show IP BGP summary. Yeah, I got two neighbors. Show IP BGP. I must be learning two networks. Now if you ping, let me go to router 1 and check the update. Yes sir, ping. Did you find this? On the other autonomous system, instead of having fully mesh, I'm going to use the route reflector, so that if you see router 2 is learning 88 from where? From 7777. Alright, from 7777 it is learning 88, and it is not from R3 or R4. It is not coming via R3 or R4. It is coming from 7777. And if you go to R6 or if you go to R5, here also you are seeing that 11 is coming from router 2 and 88 is coming from router 7. It is not coming from via any other IBGP source. Alright, so what I'll do is I'll go to router 3 and configure BGP, but not fully mesh. Router BGP, what's the number? 65531. 65531. My neighbor is 2.2.2.2. Remote AS is the same. My neighbor is 4.4.4.4. Remote AS is the same. And for both this neighbor, update source should be loopback 0. Done. So on R3 there is no configuration commands I am giving. No. It is good to give configuration command here. BGP configuration identifier is 2. BGP configuration peer is 3.2. Okay. Now I don't have any other config. I don't need any other configuration here. Now where the difference is on R2 I'll not form fully mesh. What do I mean by that? Show run section BGP. So what is fully mesh? You form neighbor with R3 as well as R4. That is fully mesh, correct? I'm going to remove R4 neighbor. Did you understand what I'm saying? So what we are trying to do is we are going to remove the fully mesh that we configured on R2. On R2, what is fully mesh? From R2 you are making neighbor with R3 as well as R4. This time we are not going to form neighbor with R4, we are going to form neighbor with only R3. You understand this? So I'll go here and say no neighbor 4444, which means I'm not making fully mesh. So what is the advantage of confederation? Reducing the number of peers. See, it's a small autonomous system. I already removed one neighbor. In big autonomous system it makes much difference. Now let us go to R4 and configure. On R4 still we need the confederation commands. So this will be 1 here and this will be 2 here, and the neighbors are 3.3.3.3 and 1 here, and with 3.3.3.3 we have update source loopback 0, and then there is another EBGP neighbor, that is this. So for EBGP neighbor we need to say update source, and also we need to say EBGP multi-hop command. That's all. We are not making fully mesh. We are not forming neighbor with router 2. Is that clear? But still I have not put the route reflector command. I'm just doing the basic configuration without fully mesh. So I'm going to router 4 and I paste this. I'm expecting 2 neighbors now. One from R7 and one from R3. Alright. Now if you see here, show IP BGP, I'm learning only 8888 from 7. But on R3 if you see, show IP BGP, this is learning 11, but it is not giving to router 4. That is what BGP split horizon is. Correct? No. That is what BGP split horizon. So what I need is I need to configure route reflector or configure or fully mesh. I'm not going for fully mesh, so I'm going to configure route reflector. Okay, let's see how to do that. Before that, I want to do some more verification here. On R4 I did everything, I believe. Okay, here let's see what it is. Here I'm seeing 8.8.8.8, sorry, 888888 is coming from 7777. 8888 is coming from 7777, which is EBGP, correct? But coming from 7777, it is not taken as a valid, it is not taken as a best one. It is just considered as valid. But coming from 2222 is considered as best. See, R3 says I'm taking this one instead of taking from 7777, because this is coming from the direct connected source. Direct connected source. Right, less IGP path. Less IGP path, less IGP cost. Now let me go and again do some configuration, reflector configuration. Before that I want to check the number of neighbors on R4. How many neighbors I see? Show IP BGP summary. Perfect. As we expected, we are having 2 neighbors, but from R3 I learned nothing. But after I configure route reflector, I will be learning some networks here. So I'll go to R3 and say router BGP autonomous system 1 route reflector client BGP route neighbor command. Neighbor 4.4.4.4 is my route reflector client. When you say this, R4 will be learning route from R3. Previously it was 0. Now I should see. You understand this? Let us see what all I'm learning. Show IP BGP. I see that I'm learning (11) as well as 88 from our router 2. Since eBGP is more preferred than iBGP according to the attribute list, 7 is not learned from R2. It is learned from 7 itself. Sorry, 88 is not learned from R2. Though it is learning from R2, it is not the best one. It is learning from 7 because of eBGP relationship. Alright. What is next? Next is I want to check whether R2 is learning route from R3. Show IP BGP BGP. Wonderful. Now I also want to say summary and show you. See, here also I am seeing 2. But on R2 I am show IP BGP summary. On R2 from R3 I am not learning anything. Why? From R3 I didn't say R2 as a client. I need to go to R3 and say R2 as client. Router BGP 3.1 neighbor 2222 is a route reflector client. Now if you go to R2, previously it was 0 here, now you will be learning 2. See? Okay, I am learning 1 now from 3333. Show IP BGP summary. Show IP BGP. I am learning 11 from my eBGP. I am learning 88 from 7, but it is shown 2 times. Meaning it is learning from both R5 as well as R3. Let us check it. This is the best command to check. Show IP BGP, paste. It will show you from where it is receiving. See, it learns from 333 as well as 555. But which one is best? Learning from 333 is best because it is directly connected. Alright. But this is eBGP relationship. This has got lower IGP cost. This is like your own network, your own autonomous system is advertising. You trust that more than coming from outside. You understand? According to R3, No, you are talking about the autonomous system now, administrative distance. I'm not talking about administrative distance. I'm talking about the attribute. See, for R2, who is more near relative? R3 is relative or R5 is relative? Because it is your own autonomous system. You want to give more respect to what you learn from R3. Correct? That's why you have this as best. Alright. Now let us go to R1 and try pinging one more time. I ping. I want to trace route and see how the packet goes. Goes to router 2, router 6, router 7, and then at last to router 8. Now if I shut down router 6, it is going by using this eBGP. This is a very directly connected eBGP. I'm sending the traffic from here. Let us try pinging from 8. Ping or trace route 11.11.11.11 with the source of loopback 88. Going to 7, 6. Okay, this also takes the same route. Alright, same route. It takes the same route because it is maybe because it is established first. Let us try shutting down one of the interface on R6. R6, I shut down interface. Goes to 7, goes to 6 and got struck. Now goes to 2. You see, this time it goes to 2 from 6, not to 5. It has taken the alternate route. You see that? Last time when you were tracing the route for the first time, it was going from 6 to, no, not here. Let me trace route from the other side, opposite side. R1. 2, 6, 7. It's not going via 5. This is because of lowest IGP cost, okay? Lowest IGP cost. Here the entire autonomous system is 2 actually. They run OSPF. It's a common routing protocol, right, for both the sub-autonomous system. So always from R2 to R5, R7, who decides the best path? It is not BGP. It is OSPF. Here comes the autonomous administrative distance. OSPF administrative distance is 110. Whereas R2 and R7, they run BGP, and here you have IBGP relationship, and here it comes from here as eBGP, but again it goes as IBGP, which is 200. So IGP cost is preferred here, OSPF cost. That's the reason. So let me bring the interface up on R6. So did you understand the route reflector and the confederation? We are able to ping from R1 to R8 as well as R8 to R1. So what we learned in this is we learned that BGP confederation and BGP route reflector are the solution to reduce the peerings that we do because of BGP split horizon. By configuring confederation, what we do is we create an eBGP relationship within an autonomous system by using private AS. Whether you use private AS or not, your sub-autonomous system numbers are not going to be advertised, so you can use any AS. It is recommended to use private AS. Whereas route reflector is more simple, you just go and say route reflector client so that the updates will be advertised from one IBGP to other IBGP.